What is line 89? Line 89 is again a call to a 0xEB. So this is 0xE8 is actually the descriptor. So let us go and see what is there in x/2x 0xD0 E8. That's what we wanted. This is pointing to this is a call gate. As you see here, the type, this is a system descriptor as a call gate of privilege 3. This descriptor privilege is 3 and it points to a code segment which is 8 and an offset there which is 100. So I need to go to a code segment. I need to go to the code segment pointing by 8 and start executing from an offset 100 from that code segment. So and this is what this thing does. So to just get an this thing, what is 0xE8? 0xE8 is actually a 32-bit call gate, which with this is not the base. This is actually the code segment selector 8, and the offset is 100, right? So what is the code segment 8 here? So let us go and see. The code segment 8 is actually is pointing to A1000, and I should start executing at A1100 here. The call gate essentially says go and start executing at A1100. And what is A1100? Please note that this is the line 0x100. So this is 1100. So in line 80, when your call gate executes in line 89, it shifts control to line 56. Call gate moves control to line 56. It is calling this. And what you do here, and here you move AX 0x18. So what is there in 0x18? So line 56. So what is there in /2x? 0xD018. Move E1000. So this is moving into GS. Base is 0xE1000 and limit is 0x100, and you know this is 4092. So this is privilege 0. I am trying to do a privilege 0 activity here. I am in privilege level 3, and just by using a call gate, now I am now trying to execute. I am executing a privilege level 0 code. So your actually here your CS is pointing to 8, which is base is 0x8000 and limit is whatever FF and PL is 0. Call gate offset is 0x100. So I start executing from A100, which is line 56. Please note that this is aligned to address A100. Now from privilege 3, I have started executing a privilege 0 code. That's what we are saying. Now what we are doing is in E040, that is GS colon, so I am moving ABCD, ABCD. So 0xE040 basically gets ABCD, ABCD. Okay. And then I do a far return because it's a far call. So I do a for return. When I do a for return, basically I come to the, I go back. So this is line number 59. Line 59 moves control to move control to line number 93. Moves control to line 93. This is the return statement. Okay. So at this point also, we would be using the stack pointer 0 for doing this call. So when we are doing this call, when I am in a PL3 segment, I need a stack of PL0. This is, I am just trying to explain you the task switching. I need to have PL0, and where will I find PL0? So let us go here, your ESP0 and SS0. So at 4 and 8, I am going to find what is ESP0 and SS0. So let us just see this. So at PL3, your ESP0 is B304. Is 50. Your ESP0 is 0x50, and your B308 0408. Your stack segment SS0 is 0x38. And what is 0x38? So again, let us go back to the GDT 0x D038, right? And it's C1000 with base 100. So this is a stack with base as 0x C1000 limit 0x100 and PL0. So when I do this call gate, all that I need for return, etc., would have essentially been done on this particular stack. So now I can check stack for check stack at 0x C1000, right? C1050 C050, actually around it, for stack switching. Because I am going from a PL3 code to a PL0 code. Similarly, also please note that the current stack for this is the C300, and this stack is at C050. For the current stack of the PL3 process is at C300, and your stack is at C050. So it's not using that stack, it is trying to use this stack. We'll check this also. I'll just put from now on some comma here, which is essentially means I have to check these things. Yes, this is to prove that I have executed this. Okay, now coming back, now I will be now trying to execute line 93. I am back at line 89. So sorry, I am back at line 93, and in line 93 I am moving line 93 to 95, I am moving into ES, the thing 0x is E3. 0x E3 is E0. So let us see what is S slash 2x, 0x D0 E0. Please note that this is a privilege 1 segment with C700 as base and 100. So this is a pre-L1 segment with base as 0x C700 and limit as 0x 100. So this obviously creates a general protection fault. So what is a general protection fault? Its number is 13. Its number is 13. Now 13 means it should be stored in 13 into 8, which is 8 3s are 24, 8 1s are 104, right? 13 into 8 is 104, which roughly in hexadecimal is 68. So where is my IDT? IDT is at D210. So I will go and find out x slash 2x 0x D210 plus 68 is D278. This says that this is 0088. Right. So this is the 88th 0x88 descriptor, and it is E5. If you see the type, it is a system. This is a task switch. Again, it is trying to do a task switch using a task state segment descriptor, which is, this is a task gate. So essentially it is trying to do a task switch and using a descriptor at 088. So let us just summarize it here. So line 95 causes a GPF. So look at the 13th descriptor in IDT located at 0x D278. IDT base is 0x D210, correct? So this shows this is a task gate and the TSS is in 0x. So what, let us see where is S slash 2x 0x D088, and this tells me this is a TSS. The TSS is at 0x B400 and limit is 0x 7. And note that this has the 32-bit descriptor. Now what happens here? So I go and see a B1400 is the task gate. Now I have to go and see what is there in B1400. So let us go and see. Now we have to see what is there in B1400. So let us go and see. So the same things that we could see here. I should say that the interrupt service routine ISR is a task with TSS at 0x B400. Now what is at, so let us first go and see where it will start executing. So where it will be as such S slash x 0x B420 is where it should start executing. So it start executing at 800 So now we'll see EIP is 0x800, and your CS, which is B44C, should give you a CS S/B44C, and it is 8. So what is 8 here? So CS is again 0x8. So this is nothing but your base is 0x8000, limit is FFFF, and PL is 0. So how do you find out? Just go to /x 0x d 0x x/x 0x d008, d008. This is 8000, and limit is quite large, FPFFF, and this is a PL level 0. Okay, so now the interrupt service routine will start executing at 8800. And what is the stack size? Let us see the other segments. S/x B1448. This is your ES. ES is null, and ES is null, FS and GS are null. So we just see ES, FS and GS are all null. Okay. And let us also see what is there in SS. SS is B450, which is C8. So your SS is 0xC8, and let us see what does that mean. So that is again D0 C8. So this C1400. So this is a stack. We start at base is C1400, and limit is 100. And let us see its thing. So this is a privilege 0 stack, right? And your DS is also very important. Your DS is 18. DS is 0x18. So what is that base? So let us see what is the base for this. This is S/2x 0x d018. It is E1000, and base is 0x E1000. Limit is 100, and the privilege level is 0. Okay. So this is how now the task state thing will start working. Now it should start executing at 8800. That is the exception. So this is, you have seen several aligns here. So you start with 8000, and you put an align 100 here. This is 8100. You put align 200. It's 8200. Then another 200, 8400. Another 200, 8600, and another 200, which is 8800. So your code will start executing here. So I am popping EBX from the stack. Which stack? It should be the 0 stack, that is C1400. Before going to that, let us also find out what is the ESP value. ESP is 0x38, right? So x/x 0xB438. The ESP is set to 50. Now here we have some small issue that we had found out. There are different V boxes that we are using. The V box is actually simulating the x86 machine. Some versions of the V box, specifically the later versions beyond V box 5 and above, they see the moment such type of an exception comes, typically a general protection fault, there is an error code that is entered into the stack. In this case, the 0th stack, which is currently pointing to C1400, ESP is 50, C450, I need to have the error code. But normally, sometimes what is happening in the latest virtual boxes, especially beyond 4, somehow this error code is not going into the stack. If you use a previous version, error code goes there. So initially we have made it null, so initially the value will be 9090 0x90909090. If the error code is not pushed into the stack by the V box, then this comparison statement at 119 will be true, because you will see. So if I pop from the stack, pop EBX that I am doing at 117, and I find that it is null, that means no error code has been pushed by the VBAX, I go and jump to this hack. Otherwise, what I do, I AND EBX with, so what will be the error code there? The error code there would be actually the segment descriptor, which is basically the segment selector which actually created the general protection fault, right? So I know that I'll get what will be in EBX here would be the index of the descriptor that actually created the fault. So in this case, E3, which is basically E0, E0 is the one which created the fault, so I will have E0 here. And why I got that fault E0? Because I am trying to use a privilege 1 segment, it should be a privilege 3 segment. So what will be there in EBX after this AND operation will be E0 if the error code has been pushed into the stack. Now what I do, I add 2004 to this EBX, so to the C3. So basically I get the second byte of the descriptor. Okay. Now please note that when I am doing this, so I am moving into ES, the value 0x10. Now you see that ES actually points to B1000. Now what is there in EBX? It is 20E7. So what is ES colon EBX? It will be D027. Sorry, D0E7. D0E7 is nothing but the second byte of second 4 bytes of E3. In this, if I am going to change the 14th bit to 1, essentially what I am doing, I am making that privilege level of that segment to 3. I am making the PL, currently the privilege level of E3 as you see here, as you see on the top is 1. By making that 14th bit of the second 4 bytes of that descriptor 1, what I am making it, what I am converting it, I am making it as PL3, right? So by making PL3, then I go and done general protection fault. If I do that, what I am doing here is I am automatically going to 20E4 because I don't have the error code. I go to automatically 20E4 and set that 14th bit to 1. That's what I am doing in this part of this code called hack. And then what I do back is I move AX comma 0x18 and push some debug info. Whatever is EBX I am pushing into this. So what is 18 here? S/x D018. It is E1000. So into DS is already so GS actually becomes 0x18, which is base is 0x E1000 and limit is 0x100 and PL0, and I am moving to 0x E020, correct? E020, some error code. This can be just 90, 90, 90, 90, 90, or it can be some E0 actually, depending on the VirtualBox version you are using. So I'll just repeat what I am trying to do. Once this GPF comes, some VirtualBoxes below version 5 actually pushes error code, which should be pushed. There are VirtualBoxes after error version 5, for some reason does not push the error code into the stack. So what we do is, we just pop EBX. If that EBX has null value, that means the VirtualBox has not pushed the error code there. The x86 machine emulator there is not pushing the error code. So I jump to hack. If otherwise, what will that error code have? The error code in the case of a GPF with such type of a segmentation violation will have the value of the segment descriptor. So I will use the segment descriptor, that should be E3. I AND it with FFF8. So essentially I get E0 here, to which I add 2004, I will have 20E7. Now I am using the 10th descriptor, which has base as B1000. B1000 plus this 20E7 will take me to the second word of the descriptor, in which I am setting the 14th bit to 1. Essentially I am changing the descriptor E0 from PL1 to PL3, and I am done GPF. In the hack, since I don't have the error code, I directly go and change that 20E4 with the 14th bit there, and that basically works here. So 20E4 and 20E4 is set here because of the error code. Normally this is better because this is more generic, but this is an ad hoc thing that we need to do because some VirtualBox do not push the error code back. And then we just go and move to this E020, this debug information of what was there in EBX. Was EBX had the null value or did it have the value?